Hello, my name is Catrin Moore, and I have a PhD together with Kat Holt in the London School of Tropical Medicine and Hygiene, and with Tariq Sadiq, based in St George's, where I'm based in Tooting in London. And the PhD that I have advertised is to look at bacteria causing urinary tract infections in people in the community in Uganda. So overall, the picture is to use whole genome sequencing to compare bacteria causing disease and those being carried in patients in Uganda. And what's novel here is these are patients who are living in one of two different areas in Uganda who visit pharmacies and those who visit outpatient clinics in hospitals, but particularly those in pharmacies, really to understand what the resistance looks like in the communities in Uganda. And just to give you some background information on the work, we started to understand some of the burden of antimicrobial resistance when the O'Neill report was commissioned and published in 2016. And the O'Neill report really outlined how big a problem the antibiotic resistance is, how many people it was killing per year. And in 2016, they modelled that about 700,000 people a year were dying because of antimicrobial resistance. But then over time, by 2050, they modelled that about 10 million people would die per year because of antibiotic resistance. And that antibiotic resistance particularly is a growing major threat to public health. Many people die, and many people there's a huge burden of mortality, but of morbidity as well. I was involved in the GRAM project, which took some of the work in the O'Neill project, where they were looking at antimicrobial resistance. So they were looking at bacteria, viruses, and parasites. But with the GRAM project, we actually looked at just bacteria to understand how many people died because of bacterial infections and how many people were affected with the DALY, so disability adjusted life years, because of antibiotic resistance. And what we found was that actually the numbers of people dying were much higher than we first thought. So between 1.3 million and 5 million people died in 2019, either because of or associated with antibiotic resistance. So, you know, having some of these numbers, estimating how many people die, is a huge step forward. But most of this work really is based on hospital data, because it's only in hospitals that you have good quality or good microbiology laboratories that can actually look at strains and work out the phenotypic resistance of those strains and which antibiotics to use to treat patients. Now, we know with the Fleming Fund that is supported by the Department of Health here in the UK, that actually many hospitals in Africa don't have microbiology labs. So only about 1% of hospitals and microbiology labs also can perform antimicrobial susceptibility testing. So that is testing the bacteria against antibiotics to see which is resistant and which is sensitive in order to treat patients, which is a huge gap. And that's just in hospitals. If we then think about what happens in communities, very little testing actually gets done. So we don't always know what's causing an infection and how to treat that infection properly if someone is maybe not so unwell that they have to go to hospital, but they need some treatment for an infection. That's why this project, so the PhD would be based nested inside a project that I have running, looking at community antimicrobial resistance in patients with uncomplicated urinary tract infections in 2 areas in the community in Kampala in Uganda. The idea is that people who go to pharmacies asking for antibiotics because they think they have a urinary tract infection, we will take samples, send those to the laboratory in Uganda and perform susceptibility testing to understand what's causing the disease, which antibiotics should be used to treat the patients, what organisms they're carrying at the same time, and the antibiotics that they're given in the pharmacy. So to try to have that holistic view of what's happening in the community in Uganda. So here we go. The project is nested within that project. The PhD project is nested within the project. And it's really to understand the resistance or the multi-drug resistant organisms that are causing these UTI infections in Uganda. And the team that we have, so myself and Kat are based in London. In Uganda, we have Henry Kajumbla, Freddie Katuku, James Kapisi, and Susan Naviga, who are all working in Uganda, based there. There's a mixture of medical doctors, microbiologists, social scientists, pharmacists, all working on this project. And they will certainly be involved with the PhD if you go to Uganda to do some training, but also to look to see what happens in Uganda, how this works. So what does this look like? So I mentioned that we have the study in 2 different areas in Kampala. We have the Namwongo settlement, which is a slum area where people are really, really crowded, living on top of each other. You have to pay to visit toilets there. And the Mwenga neighborhood, where there is somewhat more money, people have their own toilets in their own houses, and they have more facilities, more hospital facilities than there are in Namwongo. So the idea then is to take urine samples and perianal swabs to really understand the organisms causing disease and being carried, and try to get a bit of an epidemiological picture of what's happening in the area and the usage of antibiotics overall. The aims of the study. So these are overall aims, and in red here are the aims for the PhD, to look at the prevalence of antimicrobial carriage organisms in those patients, and to see how much resistance is carried by those organisms, and to understand that relationship between carriage and disease in these patients. And the outputs that I'm expecting, both with the PhD and in the wider project, are to determine those antimicrobial resistance profiles, to see if there's a difference, because we know there are socioeconomic differences between the 2 areas. I want to understand whether there's a difference in the antibiotics they're taking, and whether that then feeds through to a difference in the strains that they carry and the strains that are causing disease. And we will examine this using genomic tools, so looking at whole genome sequencing to understand those differences in antibiotic resistance. So we will look at the chromosomal DNA, but also the plasmids that the bacteria are carrying, to understand if there is a spread of different plasmids, spread of different resistance, and really get a full epidemiological picture. So that the study, the collection of samples will be over 12 months. But we'll be able to ask many questions of the biobank samples that we have. We will understand the prevalence of antibiotic resistance in this area, and maybe even be able to get additional samples to understand some of the environmental strains, and how those actually interact with what's being carried and what's causing disease in patients. So there may be a way to look at possible transmission pathways in Kampala. I think at that point, I've told you about the project, and it's worth thinking about what you might need to do if you were thinking about applying for the work. I would be looking for somebody who has some background microbiology understanding, and if you have some bioinformatic or bioinformatic practice, I guess, or use of statistical packages like Stata or R, that would be really handy. We have expertise within the group on sequencing, sort of the wet lab stuff, and also the bioinformatics. So if you don't have the skills already, you can certainly learn. I'd be looking for someone who would be happy to travel to Uganda if the chance arises, because I work very closely with my partners there, and it would be good to bring you into the team to understand exactly how these studies actually work in practice. And I think at that point, I'll say thank you very much for listening. If you're interested, please do get in touch. Either reach out to me on my email or through the MRC LID application. Thank you.